In this video, we will see the most common coding APIs that you can use in your scripts, in your game, to interact with the objects of the framework. And also we'll be talking about modifiers, both attribute and statistics modifier, which kind of modifier the frameworks provides, and how you can use them and in which order they are applied. First of all, I want to point out the fact that in the samples folder that comes along with the package, you have this common API cheat sheet that is a little collection of APIs, of the most common APIs that you will be using in your project. For an extensive, for all the APIs that are actually provided by the framework, I would rather suggest to consider taking a look at here at this documentation. That is the documentation of the package, and in the API section you actually have all the documentation about the classes, the interfaces that are provided by the framework. You have all the properties documented, the methods, so that you can find everything that is publicly available from the package here. But for the sake of simplicity here, I collected all the most common methods and properties that you will be likely using extensively in your game while interacting with the games of the projects. So here we have this dummy simple cheat sheet. We have some serialized fields that can mimic the fields that you might be defining in your scripts, in your own scripts for your game, and these fields will be actually used in the regions that we will be considering now. So we can start from experience. For experience, you probably will use a lot the add_exp method to add experience to a certain entity. You will be assessing through the entity, core, monobehavior reference, then level, and then add_exp. And you provide an amount to this. Actually, this is a long, so we can fix this, let's say, here. And however, this we have already seen in the experience and leveling video tutorial that you can attach exp sources, scripts, monobehaviors, components to earn entities in order to assign an amount of experience that a certain entity could provide to our player, for example, when they die. For example, when an enemy is slain, our player will be rewarded with the experience that entity, that enemy had attached. But also you can use this method in order to assign a certain amount of exp directly to an entity. And there is also this getter property that you can use in order to retrieve the current total experience that a certain entity has. Obviously, the add_exp method will also benefit from the experience gain modifier statistic. So if here we have a certain statistic that is then also found in our entity stats, that the value of that statistic will be considered in order to increase the amount of experience that is passed here and multiplied by the multiplier. But for experience, I would say it's enough. Like for other methods, still refer to the extensive documentation. These are just the most commonly used. For entity stats, you will be extensively using probably the get stat. This is the method that you should use when you want to read the final value of a certain statistic. And with final, I am referring to the final value that is computed starting from the base value of the statistic, and taking into consideration also the flat modifiers, the stat-to-stat modifiers, and the percentage modifiers that we will be talking soon about. So this is like the omnicomprehensive value of a certain statistic, taking into consideration all the modifiers that it may have. Instead, the getBase method will just give you the base value of a statistic. So the base value is either the value that is that the entity has for a certain statistic taken from a class. So for example, we can see that our player here is currently level 10. He is using base stats from class, and he has a warrior class assigned. And the warrior class has a growth formula for the physical attack that at level 10 has 27 physical attack. So the getBase will return this value and will also take into consideration the eventual scaling of the physical attack statistic on the base of attributes. So if we go here and see under stats physical attack, we see that we have the physical attack component and is scaling with also strength. So the base value is that 27 that we have seen here in the warrior physical attack at level 10 plus the contribution of the strength attribute that the warrior has. And if instead we are not using the class statistics on our player, but we're using the fixed ones, and we set, for example, here 10, we will be considering 10 as a base statistic plus the contribution of the attributes if he has any point on strength, as always. However, this is kind of all for the statistics. Well, you can also have one more the stat set property is also just giving you back the stat set that a currently entity is using, so that is maybe useful in some cases for understanding if some entity have a compatible stat set with some game logic that you want to perform. Then for entity attributes, you have similarly the getAttribute method that is calculating, returning the final value of a certain attribute. Either it is calculated starting from a class or a fixed one, and taking into consideration also the modifiers for that attribute, the flat and the percentage modifiers that that attribute may have. Here we also have obviously the getBase value for the attribute that is analogous to what I said for statistics, and you still have once again the attribute set property, getter property, that will return you the attribute set that is being currently used by an entity. Here, yes, we are actually to get attributes, we are assessing to the entity attributes component, and here for statistic we will be assessing through the EntityStats component. Very well, we can close a little here and here, make a little. Very well. Attributes on top of statistics have also the spendable attribute points. If you remember, in the attributes video tutorial, we talked about the fact that as our player, our character levels up, we might want to grant him some spendable attribute points that he can invest, he can spend in some attributes in order to shape the progression of his own hero. And there are some methods that you can use always on entity attributes. For example, the most important one, I would say, that is spend on. That is the method that you will be invoking when you want to spend an attribute, a point on a certain attribute. So you can either do this from the inspector, but this is useful mainly for testing purposes, but in your game your player will start from level 1, and by just playing the game he should have a certain way to assign through the game the attribute points to the spendable points to the various attributes. And in order to do this in your own scripts, you will be likely using this spend on in order to spend the attributes on the various the points on the various attributes. Then there are also two very important methods that allow to refund the spent attribute points. So, for example, you may have in your game a mechanic that allows the player to respec his character. So all the points that he has spent on the various attributes are given back so that he can reshape from the beginning the progression of his character. And you can do this through the refund all spent points, that is just giving back all the spent points on all the attributes, or you can also use refund points for attribute and is just refunding all the spent points for a specific attribute while leaving the spent points on the other attributes untouched, unchanged. And this was all also for the attributes, and now we will be talking about modifiers. And in order to better explain how modifiers work, I prepared a little sketch here to actually showcase the functioning and the order of application of each kind of modifier. So let's say that our hero has two statistics, just for the sake of simplicity, and they are the physical attack and the armor. It has as base stats, so with base stats, as we mentioned earlier, we're referring to just the fixed base stats or the stats that are coming from the progression growth formulas assigned to a class, if a class is being used, plus the eventual contribution given by attribute scaling. But let's say that the base values are 90 for the physical attack and 50 for the armor. And currently, in a certain snapshot of the game, of the playtime of the game, our hero might also have 10 flat physical attack extra bonus and 25 extra armor as flat modifiers. And you can see down here that the order of application of the various modifiers is going from left to right. So the flat modifiers are the first that are applied on top of the base statistics. So from 90 physical attack, we add the 10 extra points of the 10 plus 10 flat modifier to physical attack, and we get 100, and instead the armor goes to 75. After applying the flat modifiers, we have the stat to stat modifiers. These modifiers allow us to shape the scaling or how a certain statistic increase the value or reduces it if the modifier is negative, basing on a percentage of another statistic. So for example, you see here that we may have a modifier that says, okay, you get 50% of your physical attack as extra armor. So here, in order to calculate the value of the armor, taking into consideration also the stat to stat modifier, we have to take the value of the physical attack at the previous step. So after having applied the flat modifiers, we have to apply the percentage, 50%, and this value we are going to add it to the current value in the calculation process of the armor. So 75 coming from base stats plus flat modifiers plus 50% of the physical attack. That sums up to 125. Now, the final kind of modifier you may have with statistics are the percentage modifiers. These are quite simple, and they just add a certain percentage to a statistic using as input the value in the current at the previous step. So for physical attack we have the 100 after applying the stat to stat modifiers, and physical attack had no modifiers, is not getting increased by any other statistic, and we see here a 10 extra 10% extra, so we get 110. Instead, armor is having a 20% buff, and so if we had 125 armor at the previous step after having applied both the flat and stat-to-stat modifiers, we will be giving it an extra 20% of that 125, that is 25, so it sums up to 150. So it is important to remind that in the framework you first have the base values for your statistics, then you apply the flat modifiers, then you apply the stat-to-stat modifiers using the values of the statistics evaluated at the previous step, and this is mainly to avoid circular dependencies in the calculation of the statistics. And finally, you apply percentage modifiers. So percentage modifiers are actually the strongest one, because they use the partial value of all the modifiers that have been used in the previous steps. Very well. So in order to apply modifiers via code APIs, you can use add flat modifier for flat modifiers, add stat-to-stat modifiers, providing as first parameter the target statistic that you want to modify, as second parameter the source statistic that you will be using for the calculation of the modifier for the to-stat statistic, and the percentage that you will be using for defining the ratio of the modifier. That can obviously also be negative in order to define debuffs. So in our little example, the to-stat here was armor, and instead the source stat used for calculation was the physical attack. And finally, you can use add percentage modifier in order to add a percentage modifier. And here I want to point out the fact that the framework for defining percentages is using this specific percentage type, and this is actually just syntactic sugar for making percentage calculation in the framework in an implicit way, just under the hood, so that you don't have to struggle. But here the add percentage modifier method wants a percentage value, and if you want to express, for example, a 200% modifier plus 200%, you can just use 200 long, and this will be implicitly converted into a percentage value. Very well. Also for attributes, we have modifiers, but they work the same way, except for the fact that here we don't have attribute-to-attribute modifiers. Also because in RPGs, it doesn't make a lot of sense to have attribute-to-attribute modifiers, because attributes are actually defining the intrinsic characteristics of your hero. So strength, dexterity, constitution, they don't interact with each other, while statistics may in some cases, and because statistics are more an abstract and much wider concept, so it may make sense to have interaction in between different statistics, but it doesn't make a lot of sense to have interaction in between attributes. And if we also consider the fact that attributes can influence the scaling of the statistics, so statistics can increase their value on base of attributes, it would add too much complexity to have also attribute-to-attribute modifiers. So in order to keep the framework simple and more debuggable and more predictable, it makes more sense to have just flat attribute modifiers and percentage attribute modifiers. Then, regarding growth formulas, the most commonly, the method that is worth mentioning is the get growth value. And every time you would like to retrieve a value from a growth formula for your own scripts and your own game logic, you will be using the getGrowthValue method, where you will be providing the level that you want to access to get the growth value for. And in the getGrowthValue method, levels always start from 1, and they go up to the maximum level that you configured for that specific growth formula. Then we have scaling formulas. Here the most important method is calculate value, and it comes with 4 different overloads. You will be passing in either just the entity core for the entity that is casting the skill for which you want to use this specific scaling formula, or you may want to pass in the reference to the entity core that is casting the skill, as well the target of the skill or the attack, if there are any scaling components defined for the target. And if you are not using fixed base value for the calculation, the final calculation of the final value of the scaling formula, but you're using a growth formula for defining it, you have to also pass in the level of the skill or the attack that is being identified by such scaling formula, so that it will be calculated the correct value as a base value for the scaling formula, and it will be summed to the rest of the scaling components. So yeah, you have just these 4 methods: the entity casting the skill, entity casting the skill and the target, entity casting the skill and the level, if there is a growth formula for the base value of the scaling formula, but there are no components, scaling components for the target, or the omnicomprehensive entity casting the skill, target entity, and level. Furthermore, you have also the option during your game, your playtime, to add temporary scaling components, both for the entity that is casting the skill, the attack that is using the scaling formula, and also for the target of the scaling formula. And obviously you also have the remove. You can remove the scaling, the temporary scaling components that you assign to the formula, both for the self and for the target scaling components. And you can do this by just assessing from the scaling formula temp self scaling components getter property, and there is then the add methods for adding scaling components, or the remove method for removing scaling components. You can also, if you want to clear all of the scaling component, the temporary scaling components that are assigned to a certain scaling formula, you can invoke clear either on the temp self-scaling components or on the temp target scaling components. Next up, we have the events. We can close this region for keeping things tidy. With events, we have already seen in the events video tutorial that the most comfortable way to wire up events in the framework is by using the inspector event, the game event listeners, defining your own game events, and just you can wire up everything by dragging and dropping and define responses to events all from the inspector. But in some cases it could still be useful to have the possibility to wire the responses to some events from the code, from your scripts. And in order to do this, supposing you have a game event of any type, can be in this case int game event, but also you can use the other game events that are provided already out of the box from the framework, but also your own game events that you defined through the game event generators. They all will have the onEventRaised property event, actually, and you can use the += operator in order to add an action that you want to have called when the event is raised. And in order to raise an event, you can use the raise method, obviously. And I will also mention the fact that a really important event that you may want to use in your game is the onLevelUp event that you have inside your entity core level class, and then you can just use the plus equal operator in order to add callbacks that you want to be invoked in response to leveling up when your hero or your character levels up. This is all also for the events. And finally, we have a useful method that we may want to use when we are talking about classes, that is get max HP at. If you remember, inside the classes, you have the option to provide max HP growth formula that is just outlining how much HP a certain entity of such class will have at each level. And therefore, you can use this method if you want to retrieve the maximum HP for a specific class at a given level. Obviously, this is just the baseline value of the maximum HP, and then you can obviously, on top of this value, add your own maximum HP to your entity by defining some equipment or some debuffs, and other modifiers, obviously. And obviously, in the upcoming extension package from the framework that will be SOAP RPG Health, there will be coming much more constructs for managing more deeply the health. So this is just the baseline value for a certain class, and with the extension package, there will be given much more tools for interacting with the maximum HP even farther. Anyway, this is everything. I want to once again stress out that this is just a partial list, so if you want to take a deeper look with also the documentation for each method, please refer to the documentation, the API section of the docs of the framework, so that you can get precise information for each method of each class.